Welcome back everyone, long time no see. Today's video is going to be a little bit different. Some of you may recognize this. This is part of my compound compressor build that I did. It was running 2 of these tanks and 3 of these 3 horsepower motors. Now this thing made plenty of air, but it also made a lot of noise, and now that I've got some single phase screw compressors, I no longer need this. So I pulled off one of the tanks and the other 2 motors, and I was able to reconstitute 2 compressors, and I've sold them on. That's left me with this one, and I don't quite have enough parts to build it up as a compressor, but I'm actually working on a few projects at the moment that's going to need a vacuum pump. Now I do have a smaller unit that was being used for my vacuum chamber, but it's not quite going to flow enough, and I also wanted a reservoir in there so that if I was molding something a little bit larger, it'd be able to pull down that larger part quicker, and then the pump will kick in and pull out the remainder of that. So the size of the parts that I want to do and the thickness of the material, I don't quite think my shock vac is going to be up to the task. So since I've got this, I decided to have a look in to see whether or not I could turn this compressor into a vacuum pump. Now, having a look at the head, I've already pulled one of the heads off to check to see whether I can do it, and I think I'm going to get away with it. So this is untested at this stage, but what I want to do is I want to do the other head, and I'll probably show as much as I can of that, and then I'll get it remounted back on this tank, get rid of the frame. One thing I did notice with this build is it vibrated a lot, and now even with a single one on there, I think with these wheels it's just going to vibrate this frame too much, and I want to go back to some normal configuration running the wheels and the rubber feet on it. So this is all kind of going to be Frankenstein a bit. The wheels that were off this have been used so I can move my powder coating oven around, but I found these off one of my older compressors, and I managed to find the feet going through the old stuff. So I'm going to put it back together as much as I can, and then once it's back together I'll change the other head. We'll see if we can put some plumbing together, and hopefully that'll work as a vacuum pump. I do have a vacuum gauge that I can put on there to make sure that it is actually pulling a vacuum, and we can do a little bit of testing just with the valve on there. I'll probably end up going to a solenoid so I can actuate it with a pedal when it gets attached to the mold, the vacuum mold that I'll be working with. But for now I'll be able to just use that valve for testing. We'll see if it pulls a vacuum, and it's probably going to have some pretty rudimentary electronics for now, but I'll in the long term I'll circle back around to it, and we'll put in some kind of relays, and I've got a vacuum switch for it, an adjustable vacuum switch. So you may also notice slightly different surroundings. I've moved out of my other premises now. We're a little bit smaller, a bit more compact where we are here, but it's just a little bit more cost effective. So I'm going to get into this now. I'm going to strip this off the frame. We'll get rid of the frame. We'll get it standing on its own wheels and feet. We'll mount the compressor unit back on, and then we're going to tackle the head. So I have checked that it will fit. I can flip it over. I'll show you what to look for, and then once we've done that, we'll plumb and wire it, and we'll see whether it pulls a vacuum. So let's get at it. Now that we've got all that off the frame, we've got all these extra bits here, so we're just going to reconstitute it so it's rolling on its own wheels and sitting on its own feet. We'll put the compressor pump motor back on it, and then we'll start looking into the plumbing, and it's got a isolator switch on at the moment, so I'll just run it on that to test it at this stage, I think, and then I'll come back and look at doing some electronics later. I will install the vacuum switch now, and then all I've got to do is work out where I'm going to mount everything. I'll probably run a couple of relays and maybe a 12-volt power supply to run the relay setup, and then that'll all go through a vacuum switch that I'll install here. So we'll plumb all that, we'll test it on that wiring. So now I'll probably flick this out really quickly, and then I'll flip it on its top, and it'll make it a little easier to put those wheels and the feet back on, and then we'll look at doing some plumbing. It shouldn't be too hard. I've got a few old bits of some other compressors around with flexi hoses that should work, and the rest of the plumbing left over from when this was the compound compressor, there should be enough there to make something usable. So I'll just flip this over now and put those wheels on. Feet. So these were all the original parts I took off just because I wasn't going to need it since it was on the frame, and just fortunately I'd kept them. I do have one more set of these, and I couldn't actually find them when I was putting together the two compressors to sell, but fortunately I did find some from an old compressor, same compressor I think that these wheels are off, so I was able to use those. And I've got a little bit of money back for those compressors that I can put back into other projects. One of them being the vacuum table that I'll be putting together, the vacuum molds. But there are other things as well that I'll discuss in future videos. But for now, we'll focus on just getting this one back in some kind of usable form. It's still got the drain on the bottom of the tank there. Being used as a vacuum tank. I don't know how necessary that's going to be in future, but we'll leave it in there for now. There we go. Flip back over. A little bit low on the wheel side, but that'll be fine. So now that we've got that done, we're going to pull off one of these heads, and I'll just show you what to look out for that made this so easy. It's not going to be the same for all compressors, but this might give you a bit of an idea. If you want to do this yourself, if you're looking for second-hand compressors, just something to look out for that gives you a better idea as to whether or not this is going to work. Now that we've got that done, we can swap over this other head. So I've already done this one. As you can see, I've pulled off the intake. Now, in looking for these, this is obviously the only one that I've tried, and at this stage I'm still not 100% sure it would work. Should work theoretically, but as I mentioned before, you can see just here under the head is this little double sandwich plate, and when I remove this to check on the other head, this is where all the valving is. And the theory I had was if I just flip the valve the other way over, then that should change the direction in which the flow goes. Now, you might not have to do that on other type of compressors. You may just be able to change the ports. Because this one's got this sort of intake fitting on it, I couldn't just change the pipes, but you may just be able to replumb it if you've got, for example, like a BSP, a standard MPT or BSP fitting on there. You may just be able to replumb it, but with this particular model, they're made quite cheaply. Like even the motors here, you can see they're made up. The motor housing is just a piece of extruded aluminium, relatively cheaply cast head, and then extrusion for the cylinder bores as well. So this is relatively cheaply made, but because when I looked at this to think whether or not I'd be able to turn this into a vacuum pump, the thing that I looked at was the sandwich plate in the middle with the valves, and I assumed that I should be able to just flip it over, and quite easily that should make it should change the direction of the flow. So we'll just quickly whip this off. Now I marked these so I don't get confused what way they were, because if you pull them off and you've got one that's still set up as a compressing head and one that's set up as a vacuum head, then they're just going to cancel each other out. So you want to make sure that when you put them back together, you're putting them the right way around. So I've just marked those to make sure that if I drop it, or if I overthinking or confuse myself, I'm going to be able to have a bit of a reference to see what way it goes back on. So these can be quite long sometimes, or just the angle they're in. There we go, that looks like they're coming off. And be careful too, when these come apart, they do have seals in them or gaskets, and if you rip them, you're going to have to replace them. You may get away with silicone, but if you can avoid any damage on those seals, from memory I think there was an O-ring on one side and maybe a gasket on the other side. So if you're just really careful with it, then you shouldn't damage it. And if you can take it off all from the bottom side, I think the bottom side is the one that has the O-ring on it, then if you need to get a razor blade in the top, you'll be able to do that. So pull this off. Just be super careful. I like to try and take it off with the head. There we go. And see, as you can see, that there's just a little bit of extrusion with a piston in there. And there's all your valving on the inside there. So I'm just going to flip this over underneath, and okay, now try and line this back up without dropping it, and just be really careful that you haven't rolled an O-ring or the seal hasn't dropped out, because if you damage that seal, or if the O-ring's dropped off, you could tighten it up and crush the O-ring, and then you're going to have to replace it. Yeah, see, this has moved for me. As long as they're together, that you can get a little bit of movement out of them. There we go. I didn't bother looking out for torque settings on this. I didn't think it was overly crucial given the design of the build. Depending on the compressor you're converting, if you decide to do this, that may be different. But given that this is just a bunch of extrusion, I think it's kind of the sort of thing that if you worked around vehicles or anything like that, you should have a pretty good idea of how tight you should do this sort of thing. Obviously not too tight that you're going to be stripping threads or anything, but tight enough that you're going to get that seal. So hopefully I've done this right, and we should find out once we're all plumbed up and whether or not that's going to work properly. But I mean, in theory, having looked at the channels and the head on the other side, just by flipping that should give us a reverse flow. So now this should be the exhaust port and these should be the intake ports. So with that teeing off this way and then back into the cylinder, that should pull a vacuum. But once we've got the gauge on, we should be able to find out pretty quickly whether or not it's going to work, whether I've wasted my time or not. If so, this is probably just going to go on the scrap. that should be us. I'm just going to put this back on. This is just held on with a single cap screw. Just like that. Obviously removing it's the opposite. And I'll shift that round and then we'll look at the plumbing and we'll fire it up and see whether or not it's worked. I'm going to start by putting on this cross pipe. Now this just joins the two heads there, so you can see like a little T here, and then this will just join the left head and the right head up. Put that on loose to start with. You got to be really careful with these, they're aluminium, and if you bend them too much or if you work hard on them, they will break quite easily, so that's just something to keep in mind. There we go. They just have these like a steel coil, it's a spring shaped sort of thing, and just sits over top of there to try and dissipate some of the heat while it's running. I don't know how much it's going to need that as a vacuum pump configuration and a vacuum pump configuration, but it does put out quite a bit of heat when it's working as a compressor, so I guess we'll see when this is running whether it generates the same type of heat. I wouldn't have thought so, just given that when you are compressing air, in the same theory you would learn in HVAC, when you're compressing air, then all that heat gets jammed into a smaller area and will heat up your heads quite quickly, just like you would in your evaporator core. So this is off an old compressor. I'm hoping it's going to work. It should be just long enough from the looks of things. Same thing with these. This one's really old, and if there's too much, if you're bending it too much, oops, then you can split them. So it may be too short. Let's have a look. I may just get it. Let's see. I think we're going to get away with that. Just going to try and tweak a little bit because I don't know how well that will seal if there's a bit of a bend on the bottom side there, just because it's got a flat washer in it, and I think that if it's kind of in on an angle it may not seal, but we'll see. We'll tighten that up. Oh, may have the wrong size here. Okay, I'll tighten it up in a little bit. So next thing, I'm going to try and knock this end cap out. Yeah, there we go. This will probably be my inlet. When I'm done, I'll put a bigger fitting on there and run either a pipe coming straight off that, or hang on, I'm just going to stop that video there. I need to put some more thread tape on this and we'll come back and we'll tighten the rest of this up. Sorry about that, team, a little bit out of practice, but I'll see what I can fix up in editing, and just bear with me until I sort of get back into the swing of things. So this is just a 3/8 BSP valve, which is going to be a bit small for what I want to do, but it'll be okay for testing for now. And tighten this up as well. Hopefully there's no leaks there and it should be able to pull a pretty decent vacuum. And I'll come back through, and if there's any leaks I'll fix it up later when I go to fix up the electronics on it. So there's that there. I'm just going to run and grab the fittings I need for the, on top of here I will end up putting, I think, the vacuum switch and the little gauge there so we can see what sort of vacuum we're pulling. So I'll go get the fittings for that and we can put that together. This is the fitting. I've gone and thread taped it up and put it all together just for the interest of speeding this video up. So I've got a 1/2 inch BSP to 1/4 BSP, a 1/4 BSP T. This is a 1/4 BSP fitted vacuum switch. So you can see there's a little micro switch on the side. And this is why I'm going to do the electronics a little bit later, because these switches will not handle the current of this motor. So I'm going to run a set of relays or maybe an optocoupler or something to run through, and then I'll run a 12-volt power supply through this on a low voltage circuit. That'll trigger the relays, and then the relays will bring the motor in. I've then got a 1/4 BSP to 1/8 BSP that goes up to our gauge. So I'll just fit that on, and then we can suss out a power supply for it, and we will see, if I can get the line up, we'll see whether or not this is going to pull a vacuum. Hopefully this will line up in some kind of orientation that's usable. Something like that. And this is the one that's loose now. I think everything else is quite tight. I left this loose just because I wanted to try and set the angle that it's going to be located in, make it usable. So probably facing forward that way. Usually face that way on compressors, so probably a good direction, or maybe I'll turn it off to the side later, but that should do for now. So I think that's pretty much everything. I've got this isolator switch on there. So if I just go and grab a cable, this should fire up, and then I might have to move the camera around so we can see whether it's pulling. So let me just see if you can see that. I'll come in nice and close here so we can see what sort of vacuum it's going to pull if it works. I'll probably have to edit this a little bit, and I'll drop the volume, because just being this close to the compressor, these are relatively loud, so you won't be able to hear a single thing anyway. So I'll pull that down so it doesn't blow away anyone listening with their headphones. And you see we've got this switch here. I need to check to see whether or not it's working properly in here, or if I want to have to take it out and mess around with it. But you can see this little adjuster on the front there. So we were looking at 20, I think this is a 90 kPa, which ends up being, I think, about 26 inches of mercury, which is down here. Somewhere you might be able to see 25 around here. So we want to see if it comes up past this point. If it's going to pull further than that, and I need more for the vacuum molding that I'm going to be doing, then I might have to change a switch out if the adjustment isn't quite enough. So I'm going to fire that up. I'll bring the volume down so it doesn't blow everybody away, and hopefully this works. So let's see how we go. So that looks like it's pulled, yeah, probably more than that 90 kPa, or what did I say, about 26 inches of mercury. It looks like that's above, but it's pretty close. So that switch might do what I need it to. So I'm just going to leave it for a second to see whether or not it's going to hold a vacuum, because that'll tell me whether or not these fittings are actually sealing properly. But it's looking pretty good. So I'll just maybe do a quick walk around to show what the setup looks like now, and then when I come back later, I might do a part 2 video on the electronics to integrate this switch, because like I say, this switch will not handle the current. I can't wire directly through that. I'm going to have to run some kind of relays or optocoupler setup. So we'll come back, have a quick walk around, but so far that looks like it's a successful build, and hopefully once I get a prototype table up, I can see whether or not it's going to pull enough vacuum to do some vacuum molding. So I'm just going to crack that and see how we go with. Yeah, that feels like it's pulling pretty decent vacuum. like the idea that it's got a reservoir on there, so the pump's not doing all the work. That'll pull down a lot of the air inside of a mold and get most of it done before the pump will pull the last of it out. And hopefully, since it's not, it gets that initial rush of a large volume, and then the pump doesn't have to do so much work. And by the stage, I think the way it works is if the plastic's cooled too much before the pump manages to get the last of it out, you don't get as clean a mold. So I'm thinking with the reservoir in there, it should pull it down most of the way. The pump can finish the rest of it, and that should end up with a better finish on the molded part. So I'll just do a quick walk around now, and then we can probably leave it at that for now. We'll come back and have a look at it once I've done the electronics on it. So this will be the inlet. This is only a 3/8 inlet, but I'll change that. I'll put probably a 1/2 inch to 5/8 hose barb, and then I'll run a 5/8 vacuum line from that up to a solenoid which is on the mold, and then that'll be actuated by a pedal. So when you're ready to do your molding, you got it all sealed up, hit the pedal, that should fill the tank, and then the pump should do the rest of the work, all going well. I've just got an elbow coming straight out. I've removed the check valve. Check valve will be in the wrong orientation for a vacuum pump. You can see the model of compressor there. So just a direct drive, oilless, through horsepower. These are relatively cheap. I think like $450 or $500 brand new, but they come up secondhand quite often. This is just the test rig, just a little isolator there, isolator switch that was on the original cabinet. Once again, if you want to do one of these and have it be pretty much the same way I've done this one, this is the plate that you're looking for. So you can see here there's just this little extruded cylinder bore, and then these two plates. Sandwiched between the two plates is your valves. There's a little gasket up here. There's a gasket between them as well, copper gasket in this one, O-ring on the bottom, gasket on the top, and then you've got your head here. Your two intakes as a compressor become your exhausts. They've got a little bit of foam inside them that cuts the noise down just a little bit. That cross pipe that I was talking about tees in here, and then this becomes the inlet to the pump, and that'll pull a vacuum down there through this fitting. So this is just a galvanized pipe fitting. It's 1/2 inch. There's a little 1/2 inch nipple on there, so 1/2 inch nipple. There's probably a better way of doing this. This is just what I had lying around, and then just a little extender, female to male 1/2 inch. Then it's got this little flange nut, and then this flexi hose, and then on the other side, so that pretty much missing a bolt. I'll put that in later. And then the handle I ended up cutting up and using for part of, I think I mounted something with it on the frame there, so I'll make up something new for that. There's a switch. Just to reiterate, it was a -90 kPa, which ends up being about 26 inches of mercury. And then just a cheap vacuum gauge and just some old fittings to make it work out. And that's all I've had to do. I don't know whether or not it's going to last long enough. It should do what I need it to do in the early stages, and then I can upgrade or build something else. But for now, at least it's given me a bit of a proof of concept. I know it pulls a vacuum, and it seems to pull about the same reading as my small vacuum pump does. So it's given me hope that this should do what I need it to do. But other than that, keep an eye peeled out for the electronic side of things, and then I'll probably come back and I'll show some stuff when I get into the molding. So once again, thanks for watching.